Day 3, factoring polynomials. After today, you will be able to factor polynomials and recognize factoring patterns, the sum of two cubes and the difference of two cubes. Example number 1. Factor each polynomial completely. Example A says x cubed minus 4x squared minus 5x. So the very first thing we want to look for is there a GCF? And in this, these are all divisible by x. So we factor out an x. X cubed divided by x leaves us with x squared. Negative 4x, negative 5x divided by x leaves us with negative 5. We then need to factor our trinomial further. So our x remains on the outside. We have our two sets of parentheses. Our first two terms multiply to get x squared, so we have an x and an x. Our last two terms need to multiply to get a negative 5. So we have a 5 and a 1. We notice that this sign needs to be a negative. So I want to make my bigger term negative, my littler term positive. Quickly check your answer. So we know negative 5x plus 1x is negative 4x, and we know we factored this correctly. So our solution is x times the quantity of x minus 5 times the quantity of x plus 1. In example B, we have 3y to the 5th power minus 48y cubed. So I notice that these both have a 3 in common and a y cubed. So I'm going to factor out a 3y cubed. Then I'm going to do my division. So I have 3y to the 5th divided by 3y cubed is y squared. Negative 48y cubed divided by 3 is negative 16. I then want to factor my binomial further. So I recognize that this is the difference of two perfect squares. Y times y is going to get me y squared. 4 times 4 is going to get me 16. I need one of those to be negative and one of those to be positive so that they cancel out our linear or center term, and we're finished. Looking at example C, I can tell that they all have a z squared in common and a 5. So I'm going to factor a 5z squared out of my polynomial. So whatever you're dividing by or factoring out, put on the outside of your parentheses. Divide your polynomial. And then you need to ask yourself, can I factor this further? Well, I know that my first two terms have to be z's. I recognize that 9 is a perfect square. 3 times 3 is 9. I need all positive, so these both must be positive. And because it's a perfect square trinomial, 3z plus 3z equals 6z, and I have factored this polynomial completely. So when we are factoring the sum of two cubes, we use the formula a cubed plus b cubed is equal to a plus b times the quantity of a squared minus ab plus b squared. So you can see that our a in this case would be 4x, our b in this case would be 1, and you're replacing your a's and your b's with where they go in the equation. The difference of two cubes is going to be a minus b. So you notice that this first parenthesis matches the sign in your original cubes, and both of them have two plus signs and one negative, so you can kind of start to tell what the pattern is. These special factoring patterns must be memorized for your test. So let's give it a try. If we're factoring the sum or difference of two cubes, we want to make sure to use our formulas. So this first problem is the difference of two cubes, so I often write the formula at the top of my paper, a minus b times a squared plus ab plus b squared. And the sum of two cubes is a plus b, a squared minus ab plus b squared. So you want to rewrite your numbers as perfect cubes. So x cubed is great. We can rewrite 125 as 5 to the third power. We now know that our a is equal to x, our b is equal to 5, and we can plug those into our formula. X minus 5 times x squared plus 5 times x plus b squared. X minus 5, x squared plus 5 times x. Make sure you square your 5 and get 25. And you just factored the difference of two cubes. Looking at example B, I recognize that these both can be divided by 2s squared. So they aren't perfect cubes at this point, but when I divide or factor out a 2s squared, I'm left with 8s cubed plus 27. Well, now I recognize that my 8 can be written as a perfect cube. 2 times 2 times 2 is 8. And 27 can also be written as a perfect cube. 3 cubed is 27. So now, leave whatever you factored on the outside. You know your A is 2s, your B is 3. So you have 2s plus 3 times 2s. Be really careful that you square both of those. Minus 2s times 3 plus 3 squared. So when you expand this out, you get 4s squared minus 6s plus 9. And you just factored the sum of two perfect cubes. The next example is to factor completely by grouping. So if we have 4 terms, we can factor by grouping, which is exactly what you would think. You want to group your first 2 terms together, group your second 2 terms together. When you group your first 2 terms together, I notice that these are both divisible by z squared. So if I factor out my z squared, I'm left with z plus 5. My next 2 terms, I notice that I can factor out a negative 4. When I factor out my negative 4, I am left with z plus 5. When you are factoring by grouping, these 2 parentheses must match. So z plus 5 is going to create one of your factors. Then what's on the outside is going to create your other factor, z squared minus 4. You then want to check to make sure that it's factored completely. So I recognize that this is the difference between 2 perfect squares. So I have z plus 2, z minus 2. My z plus 5 is factored completely, and then remember, if you were to distribute this all back out, it should equal your original polynomial. Example number 4 says factor completely. So looking at example A, 16x to the 4th minus 81, I know 16 is a perfect square, and x to the 4th is a perfect square, so I can rewrite that as 4x squared. I know 81 is a perfect square, so I can rewrite that as 9 squared. I know the difference between two perfect squares is a plus b and a minus b. Four x squared plus 9, can't go any further. I recognize this is the difference between two perfect squares, so I have 2x minus 3, 2x plus 3, and I have just factored this polynomial completely. Looking at example B, I recognize that these are all divisible by 3p squared. So I factor out a 3p squared. I'm left with 6p, or p to the 6th power, plus 5p cubed plus 6. I then want to make sure I can't factor that further, but in this case it's factorable. What times what gives me p to the 6th power? P cubed times p cubed. What times what gives me 6? 3 times 2, both of my signs are positive. Let's do a quick check. 2p cubed plus 3p cubed is absolutely 5p cubed. So we know we factored this polynomial completely.